And then my favorite subject of all, storage arrays. So storage arrays are, I don't know if I mentioned this earlier, but if I could kind of have one little tagline to describe a storage array, it would be an intelligent RAID controller. Okay, not to trivialize what a storage array does, but they are providing most storage arrays, at least in the mid-range, and we're talking VNX here. It's providing RAIDing capabilities. It's protecting your data on the back end, providing front-end host access on the front end, and that's its two responsibilities. Okay, so some of the deciding factors around storage arrays and what you normally would look for if you're purchasing a storage array are really two buckets, in my opinion. The performance and availability be one bucket, and then protocols delivered would be the other bucket. On the performance and availability side, there's really three tiers within that bucket. There's entry level, mid-range, and enterprise. And when you consider these three tiers, performance is usually based off how much cache it has, how much front-end cache, and we'll go over what cache is in forthcoming lessons. How many spindles or how many disks is capable of supporting. Now SSDs really put a twist on this, but traditionally that was what was looked at. How redundant it is, that's where the availability piece comes in. Those are some items that you would address when you're considering performance and availability. Now protocols delivered are how your hosts are actually attaching to the storage array itself. So is it at the block level? Is it at the file level? Is it both? Or is it object level? Block, and we'll go over this in subsequent slides, block is really providing fiber channel, iSCSI or FCOE, fiber channel over Ethernet, data center protocols to your host. If that's the transport they've chosen, you need to make sure that your array supports that protocol. File, NFS, and CIFS. Those are the two file level protocols. Unified is a combination of both. An object would be SOAP, REST over HTTP. Those are object-based protocols delivered on these arrays. So what's block? Block is storage delivered raw. There is no file system on it. So there is no NTFS, there is no VMFS, there's no UXFS. There is no file system present on that raw device. And when it's delivered, in a sense to a host, it sees it as a local device, as a local block device. And then at that point, once it's received by the host, you can format it with a file system. Now, when you hear someone refer to block, it really comes from the smallest unit of measurement present on a storage array, which is the block. So it's very, very much applicable to the conversation and why people use that terminology. Now, when you address something or you deliver up a block-based device to a host, independent of the host OS, you're creating an abstraction layer when you create that file system. Now, most common protocols to deliver block are either fiber channel, iSCSI, or FCOE. Those are your block protocols. The partner to block is file. When you hear someone refer to file when it comes to an array, they're really referring to protocols such as NFS and CIFS, right? VNX is no different. When I think of the file side of VNX, it really is the capability of the array to deliver on these protocols. The interesting thing about the file side of things is that you're presenting block devices to what's called data movers on the file side, and then you're abstracting those block devices with a file system called UXFS. Then on top of that file system, which is really the array-based file system for those block devices, you're then putting another abstraction layer, whether it's NFS or whether it's CIFS. Now, there's other protocols like MPFS that we won't get into in this course that also are layered on top of that UXFS file system. But primarily NFS and CIFS are the two file systems that are most prevalent on file-based arrays. Now, file came from, actually it's short for file system, so you can see very much where this name came from and why it is a key term when we're discussing arrays. Unified, it is the best of both worlds. The beauty of unified systems is that it provides both file and block-based protocol capabilities. I've heard it referred to as the Swiss Army knife of storage arrays. I mean, most unified arrays, if they're able to provide both file and block-based protocols, they really can deliver to multiple use cases and performance requirements. That's the beauty of them. You're purchasing one array, but it's providing you multiple different types of availability and performance, depending on your needs. Who wants to be tied or pigeonholed to just a single protocol? I want the whole basket, the whole shebang, right? And that's what this gives you. That's what a unified system gives you. So it can deliver on fiber channel over Ethernet, iSCSI, CIFS, object, and NFS protocols. Object-based storage is one that is not as close to me as block and file-based protocols, simply because I would say it is a niche use case for it. But it really is, it's certainly the building block for cloud storage, right? I mean, I think we all understand that, and the reason is because it's not tied to a physical location. You're actually giving an object ID, and I'm simplifying this. You're actually giving an object ID to a unit of storage on object-based storage. So it's then referenced from then on out by that object ID. So irregardless of where its physicality is, you're able to address that unit of storage. You can imagine this could be very, very scalable, very, very fast and efficient. And that's kind of the point. That's why it is the building block behind cloud storage. Common data center protocols and how units of storage are addressed from a file and block perspective just would not scale in environments that are very large, such as in cloud storage environments. Most common delivered protocols are REST and SOAP, and both of these are over HTTP. So that's it. Thanks for watching. Look forward to seeing you in the next lesson.